solve problems using quadratics. Okay, we're going to have a lot of scenarios in quadratics. These scenarios come up pretty often. I'm going to show you 4 examples. Doesn't mean they're the only 4 examples, but they give you a good idea of what to expect when you're solving quadratics. Remember, solving quadratics isn't like solving linear stuff. When you solve like 5x equals 4, you divide by 5. It's like you keep numbers on one side and letters on the other side. When we solve quadratics, we need all the letters and numbers on one side, and one side has to be 0. And then we factor. We use quadratic formula, whatever the case may be. Okay, so this example, a rectangular park measures 100 by 60. I made a little diagram here, visual aid. A path of constant width is to be paved around the perimeter. So if this is a park, you know, let's say this is a park, it's full of grass. A path of constant width needs to be paved around the perimeter. That's what that means. But the mayor wants to be sure that the path does not reduce the area of grass by more than 10%. So it's a bit of a cloudy statement there. What is the maximum allowable width of the path? So first thing we do, we're going to draw this path. So I want to draw a path of constant width around the perimeter. It's going to be asphalt or whatever, right here. But I want to make sure that whatever grass was there, at least 90% remains. I can't reduce it by more than 10%. That's what I'm trying to achieve. So I have to come up with dimensions of this new park. Okay, and the dimensions are going to be similar to questions we've seen before. I have 100 and I'm subtracting 2 x's. The path over here is xy because I don't know what it is, and the path over here is xy because I don't know what it is. X on both sides, which means that this dimension is 100 minus 2x. And this dimension is 60 minus 2x. So now I have the dimensions of my new area, and I should know what the area is going to be because I know it can't be less than 10% of the original area. Well, I can find the original area right here. It was 100 times 60. 6,000 was my original area. I can't go less than 10% less grass. So this has to be 90% of grass. So I'm going to say, well, my new area, I don't know, I'm just putting n there, is going to be 6,000 times 0.9. 5,400. Okay, so I know that these dimensions here cannot exceed 5,400. So what I'm going to do is I'm going to find out when it's 5,400, and now I know that's the maximum allowable width of the path. Because if as soon as it's more than that, the area is going to be less than 5,400, and that's not allowed according to the mayor. So, do the thing that I always do. A equals length times width. I know the area has to be 5,400. I know the length is 100 minus 2x. And 60 minus 2x. It's pretty common to expand this, bring everything over, and then reduce. I am a reduce ASAP kind of person. So if you can see this reduction step, use it. So I'm going to reduce it by 2 and another 2. So you can think of it as a 4. You can get your calculator to divide this by 4. That's fine. It's divisible by 4. 5,400 divided by 4. 1350. So my next step is this actually. And all that achieves is, I know I got to reduce it after anyways, but if I reduce it now, this expansion is going to be a little faster because I'm 1/4 of the values. Okay, so same thing. I can expand this, move the 5,400 over, and to not reduce, just use quadratic formula with large numbers. It's fine, but you know me. So now, this times this, negative 50 and negative 30 is negative 80, and positive x squared. Now I gotta bring this 1350, sorry, this 1350 is still here. 1350 joins the 1500. I'm gonna rearrange this with an x squared in the front. Negative 80x, and this differs by 150, positive remains. And there is my maximum reduced equation to now use quadratic formula or to factor because I'm solving. Okay, so again, reduce it ASAP. If you can, if you want. It's not that serious. Okay, so With 150, I'm just going to do a little check. 150, 2 and 75, 25 and 6. Doesn't look like I can factor this. Okay, maybe you don't want to take time to figure out to factor it. Use quadratic formula. So, right into quadratic formula. My first step is going to be x equals negative b, so the opposite of b. I don't do negative b, just do the opposite value of b, plus minus the root of b squared. When it's easy enough for me to do in my head, I just write down what the value of b squared is. It's just 8 squared with 2 zeros. Minus 4. A is 1, so I don't write it. C. Over 2a. So 80 plus or minus 6,400 minus 600 is 5,800 over 2. Graph calculator. I'm going to do it twice. 80 plus the root of 5,800. Divide that by 2. And I'm going to get 78 as one answer. And then I got to do the minus version. Remember, if you're putting this in your calculator, make sure you're doing this, or just do the numerator first and then divide that answer by 2. It's up to you. That way you can go back and just change the sign. So 80 minus root 5,800 equals, divided by 2 equals, change the decimal, 1.9. So I got 2 answers. The path can either be, the width of the path, 78 meters or 1.9 meters. And again, anytime we have a word problem, most of the time there's going to be an unrealistic result. 78 of a path does not make sense because it's greater than 60. It's bigger than the park. That's impossible. So I have to reject the 78. And now I know that 1.9 is the maximum allowable width of the path. I'm going to read that last sentence. What is the maximum allowable width of the path? And I'm going to conclude. The maximum allowable width of the path is 1.9 meters. And you can plug that 1.9 into this black area, and you can make sure that you're going to get 5,400. Right? You can check your answers all the time. If you're doing the math right, you're probably right. Okay, on to the next one. This question is very tempting to do in like a method of your choice. You can just like kind of square root a number. You can kind of just figure it out in probably 20 seconds with a calculator. Resist the temptation, because you need to learn how to do questions that are this easy using quadratics and quadratic equations. So when they get more difficult and your brain can't really use a calculator and trial and error, you have a framework to do the questions. So do it the right way. So the product of 2 consecutive even numbers is 56, 24. We need to know what the numbers are. I didn't really set a variable here. You should be setting variables for all your word problems. Most of the time, I'm going to set a variable. And I always set the variable equal to the smallest thing that I have in the question, because I'd rather multiply and add than subtract and divide. So if I make the variable the smallest thing, I'm always going to be multiplying and adding. So my 2 equations, or if there's 2 equations, will be addition. So I'm going to let, doesn't matter what letter, I'm going to use A, feeling A today, represent the smaller number. And as soon as I set that variable, now I know that A, the product of 2 consecutive even numbers differ by 2. So A times A plus 2, which would be my second number, could also be A minus 2. That would still make it consecutive and even. So there's no difference there. Must equal 56, 24. That's my first statement. Any number A, if I add 2, it makes it a consecutive even number, equals 56, 24. Now I have to expand this, I gotta bring this over, and I have to use quadratics to solve this. So let's do it. a squared plus 2a minus 5624 equals 0. Pretty easy. Binomial and a monomial. Do you want to factor this? You probably can, because you would have done that with your trial and error method. Pretty common strategy if you're multiplying two numbers together is I'm going to find the square root of 5624, and it's 75. So like, I'm going to pick 74 and 76, 74 times 76, sorry, times. And it's 5624, so like I just found it using trial and error. I broke the 5624 into two close enough factors to each other, square rooting, and then like the two even numbers close to that square root is obviously the answer. Okay, so if you want to factor it, I'm just like fake factoring right now. It's 74 and 76, they differ by 2. So I'm going to factor this to an a and 74, a and 76. If you have no idea what I just said and did, just use the quadratic formula or factor it your own way. I'm just trying to speed it up. Signs are different. The bigger one is positive. This is positive, this is negative. So my answers are 74 and negative 76. So important to do it using quadratics because it's very obvious that there's going to be two different answers. Whereas if you did it by trial and error, you're putting 74 and 76 and you're moving on, and you're wrong because it's not the only answer. We can see from here that if a is 74, let a represent the smaller number. So I'm going to go from here. Therefore, 74 and 76 are the numbers. Because I have to add 2. Well, what about this one? You can't leave it out. If the smaller number is negative 76 and I add 2, I'm going to get negative 74. Well, guess what? Negative 74 and negative 76 is also positive 5624. So don't leave that solution out. Or negative 76 and negative 74 are also the numbers. Okay, so we have two solutions there. Show me that work. Do it using quadratics on your test if you have this question. Okay, this next common question is about a triangle. It has one leg of a right triangle is 1 centimeter longer than the other leg. The length of the hypotenuse is 9 centimeters greater than the shorter leg. So there's all these scenarios happening. Set a variable and start coming up with some dimensions using that variable. So I'm going to set let x represent the shorter leg, the smallest thing, the shorter leg. And that means I know one of the dimensions already, it's x. One leg of a right triangle is 1 centimeter longer than the other leg. Okay, so this is x plus 1. The legs of the triangles are the perpendicular side lengths, right? It's not the hypotenuse, the two legs. The hypotenuse is 9 centimeters greater than the shorter leg. This is the shorter leg, this is x plus 9. Okay, I have my 3 dimensions. Find the side length. So to find the side length, I have to come up with an equation. The only equation I can come up with a right angle triangle is Pythagorean theorem. So I'm going to say that I know x plus 1 squared plus x squared must be equal to x plus 9 squared. This has to be true. So if I know this is true, I can expand everything, bring everything over to one side, and figure out what the value of x has to be for this to be true. So I'm going to expand this using perfect squares, special products. X squared plus 2x plus 1 plus x squared plus 18x plus 81. Remember, multiply and double for the middle term. Okay, quick remembering. I'm going to bring everything over to one side. I'm going to choose the left side, so my x squared stays positive. So one of these cancels out, and I'm going to get x squared, negative 16x, negative 80. And here I have my simplified quadratic equation. Just bring everything over to one side, take extra steps if you need them. Now, with this 80, 1 and 80, 2 and 40, 4 and 20, done. I found it. Okay, quick, just check. Took me 2 seconds. I'm going to factor this with an x and a 4, an x and a 20. The signs are different. The bigger number is negative. So x is either negative 4 or x is 20. It can't be negative 4 because I can't have a negative dimension. It's not because it's negative. is because when I plug it in, it's negative. So for instance, if this smallest dimension was like x plus 100, if negative 4 goes in there, well, 96 works, because 100 minus 4 is 96. So it's not because it's negative that I'm rejecting it. It's because when I apply it, it's negative. So keep that in mind. So therefore, my answer is definitely 20. Find the side lengths. Therefore, the side lengths are 20, look at the units, centimeters, 21 centimeters, 29 centimeters. Done. Okay, pretty easy, but you can see how all these little things that we tried to train in our speed really come in handy when we navigate through this question. Yeah, Lou.
Can you start one more time? Can you explain how you use 20 something?
Yeah, so 20 and 4 give me 80 if I multiply them, and they subtract to give me that 16. 4 minus 20 give me negative 16. So the 4 is positive and the 20 is minus, because 4 minus 20 give me negative 16.
Yeah.
And then I solve from here.
No, like the x, how did you choose that it would be x? But like the 20 instead of the, yeah.
Oh, because if I plug in negative 4 over here, it's a negative dimension. I can't have, the side length of a triangle can't be negative 4 centimeters. Okay, last one. You've probably seen this in the homework, these questions where you don't even know how to start. And the reason you don't know how to start is because you have to use this formula with your information. You don't need to memorize this formula, to be honest. Like, you'll be given the formula if needed. You just have to know what to plug in. So the formula, blah, 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 can be used to model the height of any projectile, basketball, soccer, rocket, bullet, cannon, anything. Where g is the acceleration due to gravity, on Earth this is known forever. Okay? You're not getting any Mars questions, so it's always going to be 9.8, that g value. VO is the initial velocity, so I'll continue. And HO is the initial height. So these are the things that matter when something is thrown. If I throw a ball, how high am I throwing it from? Matters. How hard I'm throwing it matters. And how strong is gravity matters, because that's going to dictate how long it takes to come down. It says create a model for a bottle rocket launched upwards at 60 meters per second velocity from the top of a 3-meter platform, initial height. Then find the rocket's maximum height and how long it would take to reach the ground. Find the vertex, find the x-intercepts. So I have a framework of what I'm doing. So let's start. I'm going to go with my equation is h equals -1/2 9.8 t squared. So this is always a thing here, always. Plus my velocity is 60 t, and my height is 3. I'm going to simplify this in one step. Okay, so the only thing we have to simplify here is this value in the front, but like I said, because we're always on Earth, it's always going to be the same number, -4.9. So it's -4.9 unless you're on the moon and the question says, oh, guess what, we're on the moon, this is gravity now. And now all you have to know is, okay, the initial velocity goes here and the height goes here. This is stationary. Now I got my equation, it's negative obviously because projectiles go like this, right? They don't really go like this, so the parabola has to open down. I came up with that first model, I'm done. Find the maximum height. I've got to find the vertex. What do I do to find the vertex? Complete the square, partial factoring, you don't even know what that is because who uses that? Or the best, -b/2a. I want to find the x coordinate of the vertex. I'm going to say the t value is going to be -b/2a. So remember, x equals -b/2a is used almost always to find the vertex, especially from standard form. Well, no, from standard form. Get your calculator. -60 divided by -9.8 equals 6.12. Now, I know that the x value is 6.92. If I'm finding the vertex, the maximum height is the y value. I don't even need this, but I need it to find the maximum height. So I plug this back into the equation. But check out how I do this on my calculator. My calculator is still showing the 6.12. So that's my answer variable. So all I have to do is use my answer variable instead of t, and it'll do everything for me at the same time. So I'm going to say negative 4.9 answer squared plus 60 answer plus 3. I'm going to hit equals, and this is my answer in one step. 186.67. Therefore, the max height is 186.7 meters, and I've answered the second thing that this question is asking. All calculator work. Really quickly, I'm not completing the square. That's crazy. Okay, next. How long would it take to reach the ground? Okay, now I gotta find the x-intercepts. I'm definitely not factoring this with a 4.9 in the front, so I'm definitely gonna use the quadratic formula. You can go over here, make some space, or under here. X equals negative b plus minus the root of b squared minus 4ac. By the way, when I have a negative number, this is what I do. When a or c is negative, it's usually c because I make sure a is not negative, even though I just lied, I didn't do that over here. I just use the negative and make this positive. Because a negative times a negative is going to be positive. So instead of writing a negative here and getting confused, I just change that to a positive. You don't have to do that. Okay? Just giving you my advice. And I'm rushing here, so I'm doing the thing that I told you never to do, is make your a value negative. I would have changed all the signs. Okay, so I'm going to go here. Negative 4.9, plug it all in. And my x value is going to be 12.3. And my next x value is going to be negative 0.05. However you do to get there. Now, these are my two answers. It's not really x, it's t for time. I can't have negative time, therefore this is wrong. But that makes sense, right? If the rocket is being launched from a 3-meter platform right here up to 186, right? The intercept before is probably going to be really close to the origin, right? 0.05. It's really steep. It's getting launched upwards. Okay, my next one, though, over here is going to be 12.3. So how long is the rocket in the air? How long would it take to reach the ground? Therefore, it would take 12.3 seconds to reach the ground. And done. So remember, when you have a ball question, any projectile question, you have to convert it into this formula. Because of this 4.9, you're probably never going to factor this. So you're going to have to either use negative b over 2a to find the vertex, or the quadratic formula to find the intercepts, and then you have to rationalize whether these answers make sense. Okay, that last question could ask something else. You never know. All right, that's done, 6.5.